I'll kick things off. So yeah, welcome everyone. Thanks for joining the Manchester Java community today. First of all, just like to thank our sponsors. So we're sponsored by RecWorks. They cover our meetup fees, so we really appreciate that. So thanks to them. There's one other thing just to kind of mention. We've got some IntelliJ licenses, or I should say JetBrains licenses to raffle. So I'm going to try something new here. If you're interested in one, please put your name in chat. And what I'll do is I'll try and do a bit of a random draw towards the end, and then you can get your email address to me and we'll share the license with you. So yeah, just put your name into chat and we'll see how that works. But yeah, so on to today. Today we've got Daniel Bryant joining us. So hi, Daniel.
Hello.
I mean, I'm not going to say too much about it because I'm sure you can probably introduce yourself much better than I could.
I've got my shameless plug slide, Nick. It's all lined up.
Exactly. So yeah, I mean, I'll just hand over to you, Daniel, and let you do your stuff.
Sweet. Cheers, Nick. No, thanks for the invite. It's great to see everyone here. So I know it's a lot of stuff going on at the moment, right? And it's competition for attention is key. So I really appreciate everyone turning up. So you will excuse me if I just move various things around. It's classic with the Zoom, right? Trying to find the play button. There we go. So I'll dive straight in. So yeah, we're going to look today at easy debugging of Java microservices when you're running with Kubernetes. So the tech I'm going to show you is open source, it's CNCF tech, but it is Kubernetes specific. So some of the ideas and the principles, and I think there is even tools that are similar working with VMs, but it is sort of quite a Kubernetes specific demo I'm going to be showing you today. Let's press on. Here we go. So the TLDR is the inner dev loop when you move to Kubernetes can be quite painful with microservices and Kubernetes. Microservices, just more of them. Kubernetes adds more layers in the stack. So that real fast feedback loop we all know and love, hot reloads, can be quite tricky to get when you're in that kind of space, the cloud native ways of working. Telepresence, the CNCF open source tool I mentioned, proxies your local machine into the cluster. And the goal is to increase that fast feedback loop. We'll look at some other tools that do similar things. The interesting thing here, I've deliberately quoted proxies because Telepresence is very much a networking focused tool. You do not have to be a networking expert by any means. We've deliberately designed it and the community has contributed in so that it's not, it's super simple to use. It's not complicated, but it does offer some interesting benefits and challenges compared to other mechanisms of trying to get the fast feedback loop. So Telepresence very much network centric. It supports several workflows. We get time, I'll run through some of them. I'm mainly keen to give you some live demos and I'll be using IntelliJ actually, shameless plug for JetBrains. I know and love JetBrains. So I'll show you some ways I've used Telepresence with IntelliJ and I've got some live apps running and we can sort of debug some of those as well. But I've got some slides that go into how I've seen other folks from the community adopt Telepresence into their workflow. Because Telepresence is great for you as an individual developer, individual architect, individual QA person, but it's even better, I think, when you get it working with your team. As with many things in general, right? Great as an individual developer. Once you're all on board and your team doing things the same way, you just get that fast flow across the whole org, which is what we're all after. And it is a CNCF project. I'm banding around these terms. So CNCF is Cloud Native Computing Foundation. Appreciate not everyone's heard of them. They are awesome. And they're a big sort of foundation focusing on enabling tools like Telepresence. So they provide us with marketing support. We've donated our IP to them so that the longevity of the project is guaranteed. It does rely on folks like yourself though contributing, whether that's code, triaging bugs, writing docs, just even talking about your use cases. So as with many things in open source, one of my call outs here is get involved. It's been massively influential in my life. When I joined the London Java community 10, 15 years ago now, turning point in my career, undeniably, and then getting involved with OpenJDK, with the open source Java, was again a turning point in my career. So lots of tools are out there now. Please get involved. This is my shameless plug slide, right? At Daniel Bryant UK on most of the interwebs, GitHub, Twitter, LinkedIn. Love to chat to folks. Twitter, sorry, I'm most active on. I have written a couple of books. My buddy Abraham Marin-Prez, I'm sure a few of you may know, Continuous Delivery in Java. We wrote that one a couple of years ago now. So the Kubernetes stuff there is a little out of date, but 95% plus of that book is still, I think, highly relevant. So would love your feedback on that if any of you have ever read that one. Buddies of mine, and many folks here, I'm sure, Jim Goff and Matt Alburn, we're writing a new book that's due out, I think, beginning of next year around mastering API architecture. So early access copies are available on O'Reilly, the O'Reilly portal. I love your feedback on that as well. Brilliant. So setting the scene. I'm sure many of you recognize this, right? The inner and outer dev loops when you're coding away. So if you're doing TDD, that inner loop should be really obvious, right? You do a test, you write some code. Does it, red, green refactor, right? Does it pass a test? Yes, make it better. Once you've got that inner loop going on, even if you're not doing TDD, even if you're literally just coming up with an idea, coding some stuff, testing if it works, you're good. You then push it along to the outer loop. And you might do a git commit, you might build a container, for example. Then you're doing some more integration testing, and you're ultimately releasing and deploying to your end users too. Now, I've taken this inner and outer dev loop from Mitch Denny. Unfortunately, the blog post that was with it is gone now. It's a fantastic blog post. But someone else has sort of written a similar thing, which I've linked below if you do want to understand a bit more about the inner and outer dev loop. The reason I brought this up is that when you're using Kubernetes and microservices, the inner and outer dev loops can be quite similar, right? Particularly if you've got this like really tight feedback loop going on, but you want to access a cloud resource, an RDS, remote MySQL, or just other services, right? You can mock, sure, but you really want to test with the real thing. And then what you've got to do is write your code, build the container locally, push it to a registry, deploy it to a cluster, run your tests, and then rinse and repeat. And you're doing your system out.print lines, checking where it's going to, right? I'm sure you can remote debug, and we'll look at some of that stuff later on. But I've definitely seen, particularly more junior developers, really struggle when they've gone from the monolith on a VM to microservices on Kubernetes. They're suddenly not testing just in one monolith, they're testing in many microservices, and that inner loop gets really long if you're having to do this kind of workflow. Automation can help. Scaffold, awesome tool by the Google folks, does automated container builds in the background. So you can be writing your Java code, do your build, create your jar, and Scaffold in the background will upload that to a remote registry. So it's still uploading, still shipping the bits, so to speak, but it's all automated away from you as a developer, which is quite nice for reducing that cognitive load, right? There's Garden, there's GitCube. Draft, unfortunately, has been deprecated now. I left it in there, but Microsoft are working on this for a while. They've moved on to Kubernetes Bridge, I think they call it now, which is a new tool. Octeto doing interesting things, and the Tilt folks are doing interesting things. So we're all regularly sharing ideas. We're somewhat competitors from a pure business point of view, but the community is amazing, and we're all kind of sharing ideas to ultimately make the dev experience better for everyone. That's the key goal here. But sometimes you want this really fast inner dev loop. A lot of those previous tools focus on automating the Docker build, Docker push. And sometimes you just don't want that, right? You really want to use your own local tools. Like you want to be debugging in IntelliJ. You ideally don't want to be messing around with remote debugging, exposing ports, all this kind of stuff as well. And what folks often think then, right, I'll run everything locally. So if you're starting out, or even if you've got a bigger project, folks think, you know what, I'll just spin up everything I'm working on, Docker Desktop, Minikube, Rancher, Micro K8s, K3s, and I'll mock and I'll stub other things. And that can be a great place to be, but we've always got to remember when we're mocking and stubbing and doubling and all this kind of stuff, there's often a bunch of implicit assumptions. And if you get them wrong, well, there's drift between prod and what you're working on, there can be problems there. So, an even bigger challenge, I think, with running everything locally is once you get past a few services, your laptop just melts, right? I think Java's my native language, right? So I like to poke fun at Java, but anything heap-based, whether it's JVM or CLR on the .NET, and once you've got a few of them running, it's really hard to find space for other stuff, right? You can only get a few things running on your laptop. I've got like 64 gigs and I still struggle sometimes on my Mac 16-inch here. So this is where Telepresence comes into the mix, tools like Telepresence. I've heard it called a bunch of things. So it's fancy Kubernetes VPN for development. It's kubectl port forward, if folks have used kubectl port forward, but it's much simpler than that, but it's very similar in mental model as the way kubectl port forward works, on steroids, as someone said to me at a conference. But fundamentally, it's a network bridge between your laptop and the remote Kubernetes cluster. That's it in a nutshell, if you like. It maps your local network namespace to a remote network namespace. Just to give you some overview, we're going to be looking at this architecture today. It's real simple. The web page that's generated from this application I've got running up in GKE, I think it is, shows the architecture on the front page. So I've got an ingress set up. It's actually the emissary ingress, Ambassador open source API gateway. I've got a very large Java service, which is Spring and Timeleaf, I think it is, generating a web page. But that very large Java monolith, so to speak, It's kind of fake, but it's meant to be a Java monolith. That's calling out to a data processing node service, which in turn is calling out to a very large data store. And the data coming back from the very large data store gets modified by the data processing node service back into the Java, very large Java service. Somewhat trivial example, but it's kind of classic of what I see when folks are breaking up a monolith. They have this very large Java service, they start pulling out various bits, and those bits talk to other things in the cluster. And really, you want to work on this data processing node service in green here, right? But when you're testing it, you might want to call through the ingress in very large Java service, like a user would. And you also locally want to talk to the very large data store, because when you're running the data processing service, it does that. It talks to the very large data store. But if you run everything locally, your laptop's going to explode. You know, very large data store, very large Java service, you can't run them locally, let's just say, for argument's sake here. What you really want to do is put data processing service onto your laptop. And you can do this with Telepresence. It is a command line tool. You download a binary and do Telepresence Connect, which I'll show you in a second. It installs a traffic manager into your cluster, which basically puts a tunnel into your cluster and bridges the network namespace. So I can curl remote services locally as if I was in the cluster. And that'll make more sense in just a second. The other cool thing is you can do what's called intercepts or reroute traffic. So we can basically do a telepresence intercept in front of the data processing node service. And then when the very large Java service calls out to the data processing node service, that traffic will be rerouted, intercepted to my local machine. I can fire up IntelliJ, play around with it, debug it, call out to other stuff in the cluster and send the response back. So we'll be going via the remote ingress. Somewhere along the line, it'll be, rerouting to our local machine. We'll play around with it and we'll send it back and we'll see the results of calling that remote service. Again, this will be a bit clearer with the demo, hopefully. I think, I've actually got, here's the flow. So literally make a request, goes down to the very large Java service, hits what we're calling a sidecar, a proxy next to my data processing node service, and then gets rerouted to my local machine. And then I can also call out into the remote cluster as if I was in the cluster as well, which is quite nice. There we go, demo time. All exciting, right? It's our edgy mascot. And get you some edgy swag if you're interested. Hit me up on that one, and I'll drop down to the demo. Right. So I've got my cluster running up. I think it's the GKE one. You can just see here I've done aliasing K for kubectl. So I'm doing kubectl get services. I can do all just to show you I've got a ambassador running up in the ambassador namespace, and you can see I've got an external IP. So I'm exposing my ambassador. It's just an ingress effectively, exposing that one on that IP, and I've mapped domain names to that IP and also got a TLS certificate from Let's Encrypt. So if I just very quickly ping this and do Control-C, just to show there's nothing up my sleeve, so to speak. If I ping this domain name, you can see it resolves to the same IP address as my cluster here. So when I take this domain name, copy, bring up my browser, pop it in here, you can see this is the web page I showed you in the slides. The web page itself is just generating the architecture diagram here, but it's building various bits of this page in the Java monolith, and by calling out to the data processing service in green here. So you'll notice that the text is green on this version of the app. The color here is green, and you can see we've got 99 billion database records. We're generating the content from the cloud environment. So those are the things to watch as we start playing around with stuff. That's all good. Right, if I now head back to my terminal, let me just clear the screen to make it a bit clearer. I'll fire up, but actually I'll pause there for a second. Imagine if I'm just doing get service, and I really want to call in to the data processing service. I'd love to be able to do something like this. I'd love to be able to say data processing service .default in the default namespace. It's running on port 3000, and I know there's a color endpoint. Excuse the US spelling. I do a lot of work in the US. I obviously can't do that because I'm not in the same network namespace here as my Kubernetes cluster. So I could try and do, get pods, and then I'd look at the pods. I do a kubectl port forward to port 3000, and then I could curl localhost port 3000 and get my color variable back. But Telepresence makes that a whole bunch easier. So let me do, I've already installed Telepresence, and I'll do Telepresence Connect. Now it's going to ask me for my password because we do some stuff, my sudo password. We run a daemon locally and it does some DNS resolution and some IP tables config. So you do need your sudo password there. But once that's all set up, we are good to go. We can do telepresence list. That will show us the services available in the cluster we can play with. We can also do, I think it's telepresence status, and it will show us, yeah, we're all connected up. We're connected up to our Kubernetes cluster here. We haven't logged into the Ambassador Cloud. I'll show you that in a second, but everything looks good. If I now clear my screen and I'll run that command I ran earlier, the curl, what I'm trying to do is I'm curling my data processing service .default namespace port 3000 color. Providing I've spelt it right, which I clearly haven't. 1 second, apologies everyone. That's the danger of live typing, right? I'll do it here. I'll do curl data processing service .default 3000 color. Oh no, the dangers of live demos. 1 second. Connect. You look good. Oh no, this could be interesting. Why is that not working? Let me just look at my cheat sheet. We can always press on and I'll show you the rest of the info if needed as well. Do telepresence list. So I'm not sure what should have happened there is I should be able to curl into the cluster as if I was in the cluster. So I'm trying to curl the data processing service, default namespace, port 3000. I'm really not sure. You know what? Let me just, it is kind of cool. If I just do let's quit and then connect again. Excuse me 1 second while I just try and set this up again, clear the screen, see if I can curl. Oh, the classic live demo situation, right? That's never failed before, pretty much. So I'll break down. So what I've done there is I've telepresence connected into the cluster, and now I can curl any service remotely with the service name and the namespace name as if I was in the cluster, right? So that's kind of cool, right? I can, like, if I do get service and the very large data store, I could curl the very large data store, for example. I could curl other things. So hopefully that makes sense so far. We're now telepresence connected. We're connected up to the cluster. We can access things in the cluster as if we were local. The really interesting thing comes when we do the intercept, right? So I'll do that now. So we'll do a telepresence intercept on data processing node service. I know it runs on port 3000. So fingers crossed that one. This is now deploying a sidecar proxy to my data processing service pods in the cluster. It's an Envoy proxy. Anyone familiar with cloud native networking? Envoy is kind of the de facto proxy technology. Our emissary ingress, our Ambassador Edge stack, is based on Envoy. Many other ingresses are too. And we've got a specially customized version of that running in a sidecar pod now, doing the intercepts of the remote to my local cluster. So it all looks set up here. You can see anything now remotely that should be hitting the data processing service is going to be redirected to my local machine. See that on port 3000. So while that's doing that, I've got over here a local copy of the data processing service just in IntelliJ. So I'll spin up this in debug mode. Hopefully, many of you are familiar with IntelliJ. Very similar if you're using VS Code and other things as well. I'll make sure there's no breakpoints. You can see it's just a Spring Boot app, this data processing service. You can see it started up correctly, looks all good. If I now head over to my remote ingress URL, so this URL is going to be hitting my remote cluster up in GKE. And I've also modified the default color in my local copy to be blue. So if all goes well, if I refresh this web page, the text will change because as we're coming in for the ingress very large Java service, it's being routed to my local machine. We'll see the debug info pop up as well. You will see an error, but that's just a Spring Boot reflection error, so just ignore that. But you'll see the colors being set to blue. So fingers crossed, right? Live demo. Voila, things changed to blue. And you can actually see now I've got the graphic here, data processing service is running on my laptop. And if I, again, ignore the, it's just a Spring Boot error. If I hit refresh a few times, you should be able to see down the bottom right, it's actually calling out now the remote cluster is calling into my local service running here. Now, because I've run this in debug mode, I can do everything you'd expect in debug mode, right? If I put a breakpoint here, click refresh, you can see my breakpoint is hit. I can look at all the variables. I can look at my stack trace, for example. Let's just modify. Here's where I'm setting the blue color. If I just do view edit text, I'll set it to orange, return it through the stack, and voila, we've turned it into orange. So you imagine like my very large Java service, my very large data store are running up remotely in the cluster, but I'm now I'm changing my local copy of the data processing service. I'm debugging here, but you could just be literally coding away, right? And you imagine, someone you're pairing with, or a stakeholder, or someone else can be seeing exactly what's going on in the cluster. Sorry, exactly what's going on via my. Let me start again. Apologies. They can see exactly what's going on from the remote cluster, but interacting with my local machine. So you get a very fast feedback loop. Me as a developer now, I can do that very fast feedback loop. I can make some changes, refresh the page, see what happens, make some changes, refresh the page, but someone else could be looking onto this as well and seeing exactly that. I'll take a pause there. If there's any questions folks have got, I can show you some more advanced use cases then. We can do some selective intercepts so that not everyone will see this, the results of my local machine. I can show you about environment variables, because quite often you want to take your environment variables from your remote pod, bring them down locally. There's a nice IntelliJ plugin that helps us there as well. And I can show you how, rather than running in a IntelliJ, we can spin up a local Docker container. So if we want to keep our code tightly contained in a container, maybe we're running WebSphere or something we don't want to install on our local machines, we can do Telepresence intercept to a Docker container and do a volume mount into that with our code. So a whole bunch of cool things you can do, but hopefully that's the fundamentals of what Telepresence does, connecting your local machine into the cluster and being able to intercept or reroute traffic remotely down to your local machine, giving you that fast feedback loop. Any questions at all, folks?
Can't see any in the chat. I have one though, that's just kind of occurred to me when I was when you were introducing Telepresence. And so from a, I suppose, a security perspective, this isn't something you would have in a production environment then? I assume it's like non-prod environments. And I suppose the follow-up question to that is like, what are the kind of deployment options, I suppose, or is it like Helm chart kind of deployment for the agent running on the cluster and things like that?
Yeah, I'm with you, Nick. So we do have some folks doing it in production, but I've actually got a few slides later on that's it's dangerous, right? As in, like, it all depends on your level of risk. As in, if you're a Fortune 500 or that kind of company, you probably wouldn't want to run these kind of things in production. But we definitely have community members and customers that do. On our docs, we've got some guides to different ways to install, to your second question, because some folks, you can literally just do Telepresence Connect and it will set up everything for you, but it assumes that you've got certain RBAC permissions. It's quite limited, but not everyone's got those RBAC permissions, and not everyone's got those RBAC permissions for all of the namespaces in the cluster. So that can cause some interesting challenges sometimes. So the way when you do Telepresence Connect, you can specify certain namespaces, for example, just to hone it in, and the docs online will guide you. If you do want to do more of a platform team kind of vibe, you can actually manually install the traffic manager, and it gives you the RBAC permissions you'll need for doing that kind of thing. And then folks will connect into that cluster, but the traffic manager will already be running and not managed by them.
Yeah. Okay. Yeah.
It's a good question. Yeah. Because like all this kind of stuff, same with like SSHing into prod, that kind of thing, right? It's very analogous to that. Like I've done it, we've all done it probably if you've been in dev for a while, but you want to minimize that, and you want to have it audited and all those kind of things as well.
Yeah. Cool. Makes sense. Got a couple of questions that have come in. So this is from Mukesh. What if someone's running load tests on the cluster? Would my machine blow?
Great question. Yeah, so I've seen that. So I'll show you in a minute. You can do selective intercepts, and the answer then will be no, because you can like pass a header in. As long as you propagate a header down the stack, only that traffic will get rerouted to your local machine. But yes, you're right. Like we had a couple of customers, a couple of community members using production. Of course, all the traffic is being rerouted to their local machine, and they didn't quite grok that for a second. They were like, oh, why is this running really slow in production? It's like, because your machine is serving all of the requests. And it's like, oh, like this was actually on the previous version of Telepresence. So this is Telepresence 2 I'm showing you now. Telepresence 1 did a different mechanism. You used to what's called swap the deployment, and physically swap the deployment in the remote cluster for a proxy, whereas now we use sidecars. But yeah, that was quite comedy. And like, once you got that mental model of, yes, when you're running it in this mode, all the traffic hitting that ingress will come to my machine. If I've got breakpoint set, everyone's going to hit that breakpoint.
That's interesting. Yeah. Cool.
But I can show you the selective intercepts in a minute to get around that, because that is quite a fundamental thing.
Nice. Another question, actually. So we've got from Christian. Is my local machine visible from the cluster?
Oh, great question. No, as far as I know. I will caveat that. Well, I've never been asked that. That is an interesting question. But no, it's not like someone can reach out to your machine. It's not like you're a node in the cluster, for example. We have talked around that in the past, about putting your machine in the cluster as a node. There's a whole bunch of complexity when you do that. Pre-telepresence, we know some people were actually trying to do that. They were actually mapping their local machine as a node in the cluster, but it gets quite gnarly quite quickly. So your machine is visible in the cluster in the sense that if you hit that intercepted service, the traffic will be routed to your local machine, but that's kind of where the visibility ends, as far as my understanding is. I'll double check that though, because it's a great question.
Cool, thanks.
If there's nothing else, I'm happy to show the selective intercept stuff as well. Will not be a problem. So I'll switch to that, and let me bring up my terminal once again. I'll do a telepresence leave on the data processing service. This is just the way you leave the intercept. So now it should be all good. If I hit refresh here, green again, and you'll notice my breakpoint didn't get hit. So we're back to normal. Now I'll do a telepresence login to our cloud product. There's no payment or anything required. The way we manage, for security purposes, the intercepts does require some authentication, and it'll become clear in a minute, but I'll just log in via GitHub and do, I'll use the We Love Kate's theme. That's probably a good one. So I've just authenticated it into via GitHub now. This is actually our service catalog product. As again, free to use, no product pitch here really. You actually notice if I do k get SVC, this is a whole separate talk, but and just show you on, I think it's on the data store. Clear the screen. K describe SVC, very large data store. We've actually got some annotations here on the service. So normal Kubernetes service, as you see when you do a describe, but we've got AATR, there's a website, it's a community standard. If you pop along to aatar.io, you can add metadata to your services. And the idea being, if you're like debugging in production or something's going wrong, you can very quickly do a describe on your service and see where the code repo is for this service. You can see who owns this service, and the service catalog we've got here is just a nice way to render the AATR annotations. It parses it out and makes it look all nice with it's like service details page as well. But anyway, I've logged in now. So if I now go back to my terminal and do a clear, I'll do telepresence intercept once again. Now this time, because I've logged in, it's using a smart proxy. So we're not by default rerouting, intercepting all of the traffic remotely now. So it's asking some config around my my ingress here. So I've just used Ambassador. So this is all default stuff. I've used Ambassador. I'm running port 443 because I'm using a Let's Encrypt TLS certificate. So we are using TLS. And I'm not using SNI to do any clever stuff with host headers. So I'll press enter because that takes a minute or two to work. But you don't have to use an ingress. You can, in this config here, just specify a service in Kubernetes. But we're doing some interesting networking around headers here. So that will generate in just a moment a preview URL, which has the headers pre-configured. And once you hit that preview URL, your intercept will then be routed to your the local machine in this case. If you don't use the preview URL, you use the normal ingress, no headers added, then you just go through to whatever is in the cluster. So you don't get rerouted. So the reason it asked for details on my ingress is it wanted to know where to inject the headers, where to pass the headers on. And of course, you do need to propagate headers all the way through the stack, so that when the request hits that sidecar running next to your data processing service, the headers need to be there for the sidecar to make the decision whether to reroute it to my local machine or not. I'm in the Java world, I'm using Spring Cloud Sleuth for this. Spring Cloud Sleuth is actually designed for observability. So it's a simple import in Maven or Gradle, and I can actually show you, I think I've added, I move zoom around. It's a different service. Sorry, I can show you in a minute. I've added X Telepresence ID as a header to be propagated through all my services. Now, Spring Cloud Sleuth out the box supports the OpenZipkin headers, the B3 headers, some other headers like with Lightstep, I think it is as well. But you can just specify arbitrary headers to be propagated down through to your services. So slight aside, we can talk about that more in a minute, but what I'm showing you now, the selective intercepts, does require these headers to be propagated from your ingress all the way through your stack for what I'm showing you to work. So if I now bring up, you can see here I've got a preview URL generated. It's saying data processing service be rerouted to my local machine, port 3000, preview URL here. Copy paste that. I'll just hit this. You can see my breakpoint sprung to life in IntelliJ, so we know we're hitting local. I've left the default color as orange, pass that through, voila, get orange. So I can make my modifications here, run the breakpoint. You can actually see at the bottom here, a little banner saying you are now seeing a preview URL. You're now using Ambassador Labs and Telepresence to look through into a preview URL. Now, if we go to the original URL, which is also edgestack.me, that's our domain name. But if I go, this is the original ingress URL. If I hit refresh now, what do you think is going to happen? Fingers crossed, no change. So when I make a request going into the cluster using the original ingress URL, there's no header attached to it. I see what's in the remote cluster. This does not get rerouted to my local machine. With the preview URL, we're injecting the headers automatically. If I hit refresh, breakpoint springs to life, I pass it through, so I can do my fast feedback loop. So you can imagine two ways this is useful. I can be just coding myself now on this preview URL. Everyone else is hitting the main ingress and being unaffected. They're not aware of what I'm doing. So I got sort of like, it's almost like a private little space within my cluster, providing I don't mutate shared state or anything like that. I can be in my own little world, and nothing's stopping you doing exactly the same. You can do a login, do an intercept, and you can be rerouting traffic on the same service. So you have multiple people working on the same service, isolated by headers. You can also pair up. So I can share with you my preview URL here. I can be coding, changing stuff in my IntelliJ, and you will see. So you've got that kind of, not only do you have the private, isolated little bit of the cluster, you have a like a shared collaboration environment potentially as well, where only a few of you with the preview URL can see the changes happening. And just to prove there is no magic, if I go back, this is the preview URL, right? This is the one I've generated from my config here. If I go back to the main ingress, hit refresh, yeah, that one's not going through to my local machine. But you'll notice in the config that Telepresence tells us what it's doing. This preview URL is using Ambassador Cloud to automatically bake in an X Telepresence intercept ID with this value. So if I just take X Telepresence intercept ID, I've got things here. Yeah, I can set a header, fingers crossed. Request header, I'll put X Telepresence intercept ID. I'll take my UID there. Pop this one in here. So now I'm going via the main ingress URL. And if that looks good, if I now refresh this, breakpoint gets hit. Pass it through, orange. So we get that fast feedback loop. If you don't want to mess around with preview URLs, we find them super useful, but you can just inject the headers via sort of your curl, Postman, the browsers I've done here. Let me just get rid of that. And now voila, there we go, back to normal. So that's the whole preview URL side of it. That does require the login to Ambassador Cloud. You can do 5 intercepts simultaneously. That's free. And then there is a commercial offering with support and stuff, which you can look into if you're interested in that as well. But I find 5 intercepts gets you really far, 5 services to play around with. You just need to log in, and then you can, in the actual Ambassador Cloud, you can monitor all the preview URLs. You can see who's accessing them, a bunch of other cool stuff as well. And that's like our community edition, no credit card required. No sales pitch here on that one, but it is quite useful for keeping track of who's been looking at your preview URLs, that kind of stuff. So I think that's the that's the preview URL bit covered. Any questions there at all? Quick pause and I can show you some of the Docker stuff. That one's typically a bit more of a jump, right? You get the fundamental sort of mental model of you're connected up to the cluster. Now you can do these selective intercepts for private or for shared kind of collaboration. And now I'll show you a few extra things I think are just interesting.
Yeah, I think we're good to carry on.
Press on. Nice. So what I'll do now is if I just leave this, I'll do a Telepresence leave. Telepresence service. Now I'll also do a Telepresence log out just to keep everything simple when I'm going to do the Docker demo. So now if I clear my screen, Telepresence list, I should have my 3 services, yeah, ready to intercept, but we've not actually got any intercepts up and running. So I will shut down my local debug copy here. So then now we are not running anything on port 3000. If I go to my cheat sheet over here, and I'll show you this command. So what I can now do, I'll move zoom around a little bit. I could do telepresence intercept, data processing service, port 3000, but I'm doing a Docker run. I've got Docker up here all running away. And I've just built a container image on exactly what you're seeing in IntelliJ. I've built that using the cool functionality actually as part of Spring Boot now. Didn't even need to do Docker build, just do like Maven build container. It's very, very funky. And I've put the label as a 0 snapshot, for example. So I'm literally saying here, intercept the remote data processing service, route the traffic to port 3000 on my local machine, and spin up this Docker container to manage that those requests. So we're not going to be using IntelliJ for this example. I just hit enter, and that should spin up. You should see the all too familiar Spring Boot config if everything goes well. It's just installing in the background the all the config for routing. It's always a bit where I need some music, right, to be hovering around in the background. The Docker music. So that looks successful. That's the intercept being set up there. You saw the Telepresence intercept, and now it's our familiar Spring config up and running here, right? So if I now hit refresh, I hope I've modified the, yeah, we've got blue running there. But you notice as I've actually split the screen, as I'm hitting refresh on my endpoint, the traffic's being rerouted to this Spring Boot container running within Docker. I hit refresh. Should ideally see some more config kicking off there, but I think I might have altered the logging level perhaps. So that warning is just a Spring Boot warning, but you notice that the color changed. So we are now actually serving the local version running in Docker container via the remote ingress, because we're hitting the ingress, it's being rerouted to our Docker container. This is really nice. 2 use cases I found like of late in the Java world. You know, if you do want to run something that's a bit gnarly, like WebSphere, WebLogic, or you know, even some Glassfish configs I've used that have been quite gnarly, and you don't want to spin everything up on your local machine, you can put it in a Docker container, right? Build it, you do multi-stage builds, all these kind of good stuff, but you can basically isolate that config. I find it even more useful in the Ruby and the Python worlds. So I was working on a Spree app a while back, and like the gem installs were super old. We were doing a gem bundle, and it was a really old version of Ruby required. And of course, I can use things like RVM to like have different versions of Ruby on my machine. It gets complicated really, really fast. So one of my colleagues very kindly spun up a Docker container with that old version of the Ruby app, the Rails app running, and it was just kind of like hermetically sealed, right? And we could telepresence intercept, we can mount a volume with the code into the Docker container, and we can code, save, that gets mapped into the Docker container. We can hit refresh on our ingress here and see the changes. So we kind of kept our local machine pure of you know, not installing lots of different versions of Ruby and things, different versions of gems, but we could still get that relatively fast feedback loop because we were coding in VS Code, saving our changes, mapping that into the local container, hitting refresh on the remote endpoint and seeing the changes. So that's the Docker container. If I hit Control-C, hopefully this one will clear up quite nicely. And the final thing I'd like to show folks, show yourselves, yeah, that one looks good. I'll bring this back in. Just clear my screen. if I do a telepresence leave data processing service, leave it. Oh, that might be because I've logged out. Let me just 1 second. Oh yeah, of course I terminated that with so I left when I terminated the container. That's my bad. I didn't think about that. But I'll show you the final thing. I'll intercept the data processing service again, port 3000. This time I'm going to be generating an environment variable file, myends.txt. So I'll hit return while that's going on in the background. And this is really useful if you're doing, say, service discovery with environment variables. So if I just do LL, we can see there it is, myends.txt. It's the one I've generated. Time's pretty good for now, right? Looks legit. If I just do, well, let's do Vim, that one. You can see all the environment variables in the pod are now put into this file. So you can see like Kubernetes by default has a bunch of environment variables set up. So useful if you're doing service discovery, other things. And you can put your own environment variables there, of course, if you're doing 12-factor style apps. The cool thing is, if you need that in IntelliJ, there's a plugin. If I go into edit configurations, I've already installed the plugin. It's called mfile. Go into the JetBrains store, find mfile, and I can literally enable mfile and specify the path to that file I've generated. So this is super useful. VS Code is exactly the same thing. I think VS Code by default likes it in JSON format. So there's another command in Telepresence to generate environment variables in JSON format as well. But this is super useful if you really want those environment variables because your local app requires them to maybe do feature flagging or different profiles and Spring Boot, that kind of stuff. You can easily get your environment variables from Telepresence too. Right, I think that's the end of my demo. Checking the cheat sheet. Yeah, anything else? I know we're getting pretty close to time as well. I appreciate everyone's attention. Any other questions folks have got?
No questions in chat. I'll give people a minute and let things percolate. Yeah, no, that's kind of really cool. So far, very interesting.
Once you get your head around the sort of the mental model, I think it's super useful because for me, like the debug sort of life cycle before, yeah, you can do remote debugging, but then you have to set up open ports and Kubernetes and stuff. And I like Scaffold a lot, and I use Scaffold actually quite a lot. I use Scaffold and Telepresence in combination quite often. But once you get that sort of that fast feedback loop with Telepresence, it's suddenly like, whoa, like I can work really fast rather than having to build a container every time, which is kind of nice.
Yeah, yeah. We have a question, which is good, from Mukesh. Is it possible to block Telepresence on a cluster?
So prevent it being installed, I guess.
I'm thinking that's probably, yeah, what they're kind of
getting. Definitely, Mukesh. Yeah, so you most likely do it with RBAC, right? So like we do definitely run a lot of folks in there. We've got a Slack channel. Everyone's welcome to join the Ambassador Lab Slack, and folks do download Telepresence, try and run it on their cluster, and the admins, the platform team have deliberately disabled various things, RBAC or restricted RBAC permissions. So yes, you totally can do that. If you wanted to be like, I don't think you can really get around that, to be honest, like with a few sensible RBAC permissions. But if you needed those RBAC permissions and still didn't want to run Telepresence, you could probably like create yourself an operator to automatically stop it, or use was it like Gatekeeper and OPA, like to do some emissions like checking. So yes, there's plenty of options there, I think, if you really did want to sort of lock it down, but RBAC would be your most common approach.
Cool. We've got a question from Craig. I think he can unmute himself, so we'll see if he wants to ask it, but if not, yeah, so I'll ask it anyway. So he said it's not a question, just an observation. So he's spotted that you've got a gopher nicely displayed on the shelf and not a duke.
There's a duke there as well.
Oh, is there a duke? Oh yeah, small one. Yeah, there it is.
Yeah, that's the problem. Like the gopher folks, the Go folks have got their on branded, the branding sort of a bit more in your face, right?
So the follow-up kind of question was: is Golang a language you like to use?
You know what? I say Java's my native language in this space. My second most comfortable language would be JavaScript. But in the cloud world, Go is super popular, right? In terms of hipsterness, Rust would probably beat it. I was chatting to someone else earlier in the week, and they're like, "You don't code in Rust?" And I'm like, "No," but that is like super hipster. So yeah, I think a lot of folks I chat to in our community are using a combination of things. The more modern companies tend to be leaning towards Go and Python, in my experience, and with a bit of Java perhaps in the stack. But the folks that have been around a while have a real gamut of things. There's nearly always, and this is biased by probably who I chat to, because they know I'm a Java person or whatever, but there's nearly always, Java running the show with a bit of JavaScript in the mix, a bit of Node typically, a bit of Python for data science. And then a lot of new services I was finding up until 6 months ago were being built in Go. And so a lot of Java developers cross-training in Go. But now with the advent of Quarkus and GraalVM becoming a bit more mature, I am seeing more and more folks now, rather than going to Go, if they're Java natives, they're using things like Quarkus, Red Hat's microservice framework, and you can compile native binaries. So I was playing around with it like over the holidays earlier in the year. Super cool. You can, you got to follow a bunch of rules, so to speak, a bunch of guidelines, but you can get very low footprint Java applications. You bring all your Java knowledge with you, but using Quarkus and Graal, you can compile down very small, low memory footprint images, which for me are competitive with Go. So long answer to folks there, but as in, I think if someone instantly says to you, you've got to learn Go because Java's not fast enough or it takes up too much memory or something, I'd push back a little bit and go, hey, let's check out MicroProfile. Let's check out Quarkus. Let's check out these other things. Quarkus in particular has caught my attention of late.
Yeah, I've seen that. They're all maturing, aren't they? And I think Quarkus is specifically markets itself as Kubernetes kind of.
It does, Nick, doesn't it? It does.
Yeah, so they've made some decisions that are kind of, I suppose, less general purpose. I think from what I think we had a meet up a couple of weeks ago, and what they were saying was like things will work on any platform, but they're optimized for Kubernetes, and it kind of, because of those optimizations, they're just generally kind of good practices, I think. And
that's it. It's a cool, I had a bit of challenge getting some things working like Graal and Quarkus and stuff. So any new text like that, right? Once I got it working, I was like, whoa, this is like tiny little image and Docker file. I was like, this is pretty cool.
Yeah, no, it's cool. Craig just says, I wanted to love Go, but hate it really.
Nice one, Craig. It's a different mindset, right? Like I've loved learning languages over the years. But like some of the stuff, I remember like people used to say to me with Java, they were driven nuts by the exception handling. But in Go, the exception handling is even worse, right?
Yeah.
So error equals nil all over your code base.
Yeah. Well, that's funny. Cool.
I've got a final slide, folks. Because I've got some other things here which I'll share with you all. There's more sort of referencing what I've just talked through. I would say, folks, I'll just quickly. Folks often ask, like, I could just build a proxy myself. Why do I need to use Telepresence? And I'm saying the classic hack and use post, right? This looks so simple. Get this at every conference I go to. I could just build Telepresence myself. And yeah, you could, but it's really gnarly for a bunch of reasons. DNS routing, proxy connections, Kubernetes is different resource types, your laptops aren't alike, your clusters aren't alike, whole bunch of things, right? And the fact it's a CNCF project means like lots of people are contributing. There's lots of people running it. We have, if you look in our Slack, it's like 3,000-4,000 people. You can see some of the organizations involved. So, Telepresence is very much a CNCF project. Let's all put our energies into like these kind of projects rather than trying to spin up our own thing, is my advice as well.
Yeah, that's fair.
Yeah, and just finally, if you want to contribute, we'd love pop along to the Slack or the GitHub repo. Reach out to me, for example. I can point you in the right direction. No contribution is too big or too small. We'd love to chat to you first about some of these things, but it is very much a community project. So yeah, love folks to get involved.
Awesome. If you've got time, another question has come in.
Rock on, Nick.
So it's a very good one as well. So thinking about Telepresence, what does it offer in terms of being able to monitor Telepresence specifically? I suppose thinking about, does it expose Prometheus metrics for itself around its kind of behavior, what it's doing, traffic it's handling, I suppose, those kind of things. I'm guessing a little bit on the kind of detail, but.
Great question. That was not one I've been asked for, actually. I've done a whole bunch of these talks over the last 6 months. You know what? It doesn't do much in that regard, in all honesty. It's more of a dev tool. So we've got logs locally and logs obviously remotely in the cluster for your traffic manager and your sidecar proxy. So you can always look at the logs and see what's going on. Yeah. But we don't actually, other than what you'd have, as part of just standard egress, we don't really have any metrics in that regard, because everything's going via TLS as well. So all the traffic's secure. So you can't like sniff the traffic content per se. I've never been asked that. It's a very interesting question. Most folks use it more as a as a tool for development, rather than something, say, like an ingress or a service mesh, where they do, because it's running all the time, they want to observe those things. Like Telepresence is almost like a remote debugging enabling tool, I guess. Great question. Let me think about that one.
I suppose it's just made me think about another question, actually, if you've got time. And so if you use an Istio on your cluster and got a service mesh, does Telepresence integrate with the mesh?
Yeah, great question, Nick. And so we've definitely got folks in the community using Istio and got it working. There's a few quirks though with it. So we're actually planning to put some documentation up like real soon. We've got it working with Linkerd. So we see a lot of traction with Linkerd as well. We know in like the Buoyant folks behind Linkerd. We know in like the Istio folks. We know in like everyone, of course, but particularly we've done a lot of work with Buoyant of late. They're great people. So we've got already, it went up earlier this week, I think, a doc to how to use Telepresence with Linkerd. If you're running Linkerd as your service mesh. We do a lot of work with HashiCorp folks as well. We love HashiCorp. And Nick Jackson's done some cool demos around console as a service mesh with Telepresence. We haven't got that fully docked yet, I don't think. And the Istio stuff, if you look, we've got a couple of documentation pages that talk about how to use MTLS, because quite often folks with Istio, the two use cases are observability and MTLS, so mutual transport security between services. So you need to let Telepresence know about the certificates, and there is some command line flags in Telepresence. That's, if you look in the Telepresence binary, you'll find them, like as in Telepresence -- help, and you'll also find them if you search on the Telepresence docs for Istio or MTLS with Telepresence, you'll find the guide there as well. I'll try and put a demo for that together soon, because it's becoming an increasingly popular question. Folks we see a lot of Linkerd, for example, out in the world.
Yeah, makes sense. Got another question, if you still got time?
Yeah.
Cool. So this is from Christian. Is Telepresence only for Java services? Wondering how it can help in my case, where apart from my Spring app, I have RabbitMQ, MySQL in the stack. Any integration there?
Yeah, great question. So it's language agnostic. So like I regularly do like JavaScript demos and Go demos as well. So you can intercept any HTTP traffic. So HTTP 1.1, 2, gRPC, GraphQL, for example, WebSockets, I think. Yeah, I think you do that. Any HTTP traffic can be intercepted, but looking into the cluster, so like when I'm on my local machine looking into the cluster, any TCP is supported. So a common use case I do, for example, if I've got MySQL running in the cluster, is I'll just do Telepresence connect and be able to run the MySQL command line or MySQL, admin locally, connecting to the remote cluster. So that is kind of a cool use case. Rabbit, same deal, right, with TCP. When, just an FYI, we had a few folks in the community messing around with or experimenting with Rabbit and Kafka, and you've got to be careful, because when you do the intercept, you don't replace what's running in your current cluster. So we had some interesting kind of use cases where folks were trying to consume messages locally, but they were getting consumed in the cluster because there was still something running in the cluster. So what they had to do is do Telepresence intercept, shut down the service they were intercepting in the cluster, and then consuming messages locally, that kind of thing. So pop along to the Slack if you want to know more about that. There's some good messages around that kind of thing. But fundamentally, it's a common use case of Telepresence connect and then interact with remote data stores in the cluster.
Great stuff. Excellent. Well, yeah.